Okay, so welcome back, and today we are going to start talking about other formulas that we've used in the Cartesian plane using XY coordinates that we're now going to start talking about in polar coordinates, and how do we do the same sorts of things with polar coordinates. So just as a review, remember we discussed in previous chapters, previous videos, that if we have a function of x, right, y equals f of x, over a closed interval for x, right, the domain from a to b, where f of x is positive, okay, for that, over that interval, then we could define the area, right, under the curve, between the curve f of x and the x-axis by using this integral, okay? And we could solve these by using the fundamental theorem of calculus. Now, we also talked about arc length, right? So we've talked about arc length in the same context. So here's our formula for arc length when we were dealing with the Cartesian plane. So what we're going to do is in the next few videos for this topic is going to be, how do we do the same thing for polar coordinates, right? So if we had things in polar coordinates, how would we set up analogous intervals, or not intervals, but integrals, but we're dealing with polar coordinates, okay? So that's what we're going to do in the next few videos, is we're going to start with area, and we're going to derive integrals for area of a curve, in this case a parametric curve, right, a polar curve, and also for arc length of a polar curve. So that's what we're going to do, and it's going to be interesting, and in some cases it's going to be easier to find the area for some of these polar curves because of the way the curves are created. Like, for example, we're going to talk about roses, limesons, cardioids, and then talk about the area between curves, polar curves, like between a circle and a cardioid, or a limescon, or something like that, or a limeson. But anyway, that's what we're going to do next, and we're going to start by deriving these formulas, and then we'll do some examples and apply them. Okay, see you then.